Hi, today we will learn about dimensionality reduction in data science, optimizing machine learning by specifying complex data structures. Why reduce dimensions? Efficiency. High dimensional database requires immense computational power and storage. Reducing features accelerates training times and lowers resource consumption without significant information loss. Interpretability. Human cannot visualize data beyond three dimensions. Reducing dimensions to 2D or 3D allows you to cover hidden patterns, clustering, and outlines other visualizations. The curse of dimensionality. As features increase, data becomes sparse. Sparsity. In high dimensional spaces, data points are far apart, making it hard for algorithms to find patterns. Distance matrix. Euclidean distance between meaningfulness as all points become roughly equidistant. Data requirement. The amount of data required to generalize accuracy grows exponentially with dimensions. Combating overfitting. A signal versus noise. The high dimensional data often contains redundant or irrelevant features, noise. Models may learn this noise instead of the underlying signals. By removing these dimensions, we force the model to focus on the most significant predictions, involving its ability to generalize to new unseen data. The two main approaches is feature selection and the feature extraction. Select a subset of the original features, keep the best, discard the rest. Retain physical meaning, better for interpretability. For feature extraction, create new features for combination of original ones. Transfer and compress. Lose original meaning but captures complex relations. The feature selection techniques, which some are filter methods, wrapper methods, embedded methods. For filter methods, statistical tests select features independent of the model. Example: correlation chi-squared. In the wrapper method, use a specific model to evaluate subsets of features. Example: recursive features elimination. In embedded method, selection happens during mode training. Example: lasso regression L1 and random forest importance. Principal compatibility analysis or PCA. The linear approach. The PCA is an unsupervised linear dimension technique. It identifies the principal components. Direction from the data varies the most. The goal is to maximize var projection. It produces data onto this new orthogonal axis, effectively compresses the information into fewer dimensions while retaining maximum variance. Visualizing the transformation from 3D to 2D. The visualizing demonstrates how the 3D cloud of data points is projected onto a two-dimensional plane defined by the first two principal components. Note how the spatial space relations are clustered and preserved in the low-dimensional views, making patterns easier to spot. Non-linear extraction, bound linearity. The complex data often lies in the curved manifolds, like a Swiss roll. Linear methods like PCA fails here. So TSNE or autoencoders we use here. So TSNE is great for visualization, preserves local structure, neighbors stay neighbors. In autoencoders, neural networks that compress data into a bottleneck layer and reconstruct it. So the head-to-head comparison between these are for feature selection and feature extraction are. So the method for feature selection is subset of originate, and the method for feature extraction is new syntactic extraction. The interpretability for feature selection is high. Physical meaning of the selection remain high. The interpretability for feature extraction is low, which is an abstract components. The complexity for feature selection is simple and fast. The complexity of feature extraction is computationally intensive. Its best for feature selection is removing irrelevant variables, and best for feature extraction is compress complex data, images, and audio. The key takeaway from this is prevents overfitting, reduces noise and complexity, leading to better generalization, boost performance, fast training, and intense times for modules. Enable visualization, makes higher dimension data understandable for humans by making from 3D to 2D.